So good evening again. Barely seems like 5 minutes I was last talking to this group, but there we go. So here we have A Week Above the Clouds. As you can see from the subtitle there, it's about an astronomy field trip to Tidy Observatory in the Canary Islands. And you can see from the two badges there, University of Liverpool and Liverpool John Moores University. These are the two biggest universities in Liverpool, and some time ago they got together to make an astrophysics degree, a physics with astronomy and an astrophysics degree program. And the degree program is delivered jointly by both universities. So any student that wants to do astrophysics becomes a member of the University of Liverpool and a member of Liverpool John Moores University. And if they wish, they can get 2 degrees at the end of it. So this is about the field trip that these students go on after they've done 2 years of their undergraduate degree. So this is already out of date because clearly I've said here, every year we take our students on an observing field trip to the Canary Islands. It will come as no surprise for you to learn that this didn't happen last year. So for the first time, we were not able to take our students on a field trip, which means there's a cohort of students who've missed out on the experience of having an astronomy field trip to the Canary Islands. And unfortunately, we're going to have to do the same this year as well. So a great shame. But what I'm describing is basically what we have been doing for the past few years. And we take the students from Liverpool to the Canary Islands. There they are for those whose geography is not too strong. There's the Canary Islands just off the coast of Western Sahara. So there's the Canary Islands in a little more detail. The island of La Palma over on the left, but in the middle is the one we're interested in because Tenerife is where we take our students. So let's blow that up a little bit. Right in the middle of Tenerife is Mount Tidy, a dormant volcano. And the red circle there, the red ellipse, gives you an idea of the size of the caldera. And right on the edge of the caldera is where the observatory, the Tidy Observatory, sits. In common with a lot of other sites, if you want the best observing conditions, you don't put it right on the peak of a particular mountain. You either put it on the side of a mountain, or in the case of a volcanic island, you put it on the caldera where the air is at its most stable. For those of you who know Tenerife as a tourist destination, you'll know that a lot of tourists go to Tenerife, but all of the touristy areas are around the coast. You can see at night there's essentially no light coming from the centre of the island. All of the light is coming from the towns on the edge, Santa Cruz and Puerto de la Cruz. So it's nice and dark in the middle, and although the towns at the edge of the island do produce some light pollution, those towns are sitting underneath, generally speaking, some sort of a cloud cover, and that light doesn't usually make it up to the observatory. We don't tend to observe objects on the horizon anyway. We, of course, tend to look at objects a little higher in the sky. So any light pollution is not a problem. But one advantage of having all those tourists not so far away is the fact that the flights to Tenerife are very cheap. So in other words, sending students to Tenerife doesn't cost us an arm and a leg because we can get the flights at a reasonable package deal, as it were. So let's zoom in on the observatory. The observatory is on a sort of a ridge. Let's zoom in a little bit further. And there we can see there are a number of telescopes in Tidy Observatory. There's some of the world's largest solar telescopes. These two on the right-hand side are solar telescopes. These are world-class telescopes. There are some smaller optical instruments, like an optical telescope down here and an infrared instrument. But the telescope we want the students to use and learn about is the telescope that's right in the middle here. Let's zoom in once again. This is the so-called MONS Telescope right in the middle. The students themselves, we all live up there. We don't come down from the observatory each day. There's accommodation on site, so the students have a sort of dormitory over here, and if we take anything from half a dozen to a dozen students at a time in any given week, we'll have 2 or 3 or possibly 4 staff who tend to have a dormitory either separate from the students, always good to be separate from the students, or possibly in a restaurant area in a slightly different building. But the limit to how many we can take at a time is dictated not by the size of the telescope or the working area of the telescope, it's dictated by how many students can sleep there in any given day. So we're limited to taking 12 at a time. So if we have a year of 25 or 35 students, and they all want to go on the field trip, which generally they do, then we take them out in batches. We take out 12 in 1 week, and then another 12 come the next week, and we chop and change every week to give each of them the experience of being there for 1 week. If we have a look in a little more detail at the MONS telescope that we use, correction, that's just a general view of the undergrowth. There's Mount Tidy in the distance there, and you can sort of see the edge of the caldera here. This is just some of the undergrowth, which is rather scratchy, but we'll come back to that later. Let's have a look at the general view. There's the MONS telescope, and it's got a warm room next to it, which means students can plan their observations and do the analysis of the observations that they've made before and after taking observations from within the dome itself. There's a few other telescopes in the distance which I won't go into, and you can see that we're looking down on the clouds from an altitude of something like 2,500 meters, so we're looking down some distance. This is looking at sunrise over the cloud bank, and here you can see in the distance that's the island of Gran Canaria in the distance, just poking up above the clouds. But you notice that one nice thing about this telescope, not only do we have a telescope and a warm room next to it, just out the back we have this large open area where some of the scrub has been cleared. They've laid some concrete and provided a little bit of power, which means that's an ideal place to do a little bit of astrophotography in any idle moments when we're not supervising students. We can simply come out of the back, set a camera up and do some astrophotography, which I'll show you later. So, sunsets at about 9:30. How long are the nights in Tenerife? Well, we go in the summer because that's the only time we have enough time after the students have had their exams. That's the only time that we can really get them out there. It may not sound like the best time to do astronomy in the middle of summer, but because of the latitude being about 28 degrees north, we get about 10 hours between sunset and sunrise. So we get a reasonably long night, even in the middle of summer. But the time zones in Tenerife are a bit weird. We are further west than Greenwich, but the clocks are always forward compared to Greenwich. That's simply because Tenerife is the Canary Islands, which are owned by Spain, so the clocks are on Spanish time, even though we're on the wrong side of the meridian, as it were. So the sun sets at about 9:30, so we tend to have an evening meal all together. All the staff and all the students have an evening meal between 8 and 9 o'clock, and then the sun sets at about 9:30, and then we all trog up to the observatory to start the evening's observing. The telescope that we use is the MONS telescope. It's got a 1/2 meter mirror, a 20-inch mirror, and it is a large manually operated telescope and weighs probably 1/2 ton or so. It's called the MONS telescope simply because it used to be, excuse me while I just move the camera, it used to be in MONS University. And it was moved from MONS University, I can't remember how many years ago. It was a research telescope, but it's now moved onto site as a very useful teaching telescope. So it allows the students to get used to using a large telescope without throwing them into the world-class telescopes that are dotted around the rest of the site. In this image and a few other images that I've taken inside the dome, there's actually not much in the way of red light in there. It looks quite bright, but this is a relatively long exposure of 2 or 3 seconds, which is why all the students appear to be thoroughly blurred. They don't always look like that. We get them to use the telescope with an eyepiece just to give them an idea of what it's like to look through a large telescope, and then we switch over to using CCD cameras and filter wheels. But we get the students to use a manually operated telescope because we think it's important that they don't learn astronomy by just sitting down at a computer. Now, professional astronomers will do precisely that, Professional astronomers don't go groping around a telescope most of the time. They sit at a computer, they say where they want the telescope to point, and off it goes and points in that direction. But here we want the students to learn the art of how to use a telescope. So we want one that's manually operated. Yes, it has motors for right ascension and declination drive, but it does not have a go-to facility. If they want to point this telescope at a particular galaxy, they have got to work out how to point that telescope at that galaxy. So we split them into teams of usually 3 or 4 students, and we teach them the wherewithal as to how to get a telescope to point in a given direction with an equatorial mount. They're not used to using these things. Very few of these students have actually got any experience using a telescope, let alone a large telescope. And so we have to teach them how to work as a team and how to operate the telescope even in complete darkness. Okay, some of the time we have red light, but there are times when they have to be able to operate in the dark. So for instance, one student might be releasing a lock for a particular motion, another student might be hanging onto the telescope to make sure it stays pointing in a given direction, another student might be reading off setting circles. In this particular case, there are 4 students here in the dome. There's one on the left you can hardly see, who's hanging onto the counterweights just out of picture. Student on the right is hanging onto the telescope and is moving it in a particular direction. There's also a student there with a motorized paddle such that once the telescope has been locked into place, they can make fine adjustments on the paddle. And the student here at the back is reading off the setting circles. We expect the students to be able to point the telescope to accuracies of order arc minutes. If they want a particular galaxy to be in the middle of the chip, then they have got to point that telescope accurately. In some cases, the object is not visible through the finder scope because it's too faint. So they have to calibrate the setting circles, they have to figure out the coordinates of the object in the sky, they look up the coordinates, they have to process the coordinates because most coordinates are given for the epoch 2000 and we are now 20 years later, so precession of the equinoxes means that all the objects in the sky have moved slightly. The students know how to do this in theory because they've been taught everything at the university. Now they are putting it all into practice. Find the coordinates, process the coordinates, calibrate the setting circles, point the telescope in the right direction, and hopefully your galaxy should be somewhere near the center of the CCD field of view, which typically is maybe 10 or more arc minutes across. So it definitely gets the students thinking about how the sky moves, how the telescope moves, and how they ensure that they have the right accuracy to get the object of interest. We split the students up. If there are 12 students, they might end up in 3 groups of 4, for instance. If there's 6 students, we might put them into smaller groups. But the idea is either 2 or perhaps 3 groups of students will work throughout the night. Students will plan what they want to do. They'll think about what objects they want to observe with the telescope. They'll spend a little bit of time doing that. Another group will be in the observatory taking their data, making their observations, whilst a third group perhaps will be analysing the data they've just taken, and they simply cycle through that a few hours each throughout the 10 hours of the night. They might spend a few hours planning, a few hours observing and taking data, a few hours analysing their data to see what it is they've got. Most of the serious analysis takes place once they return to Liverpool the following year. Remember, this is done during the summer, so they take quite a bit of data during this week, but the real hard analysis comes the following semester when they rejoin the university in September or October. They do some preliminary analysis during the week to make sure they've got what they think they've got. The serious analysis comes as they write up their projects the following year, in usually their year 3. But this is the warm room where it's fairly comfortable, often work in red light to preserve the night vision for the next group of students who are going to go up to the observatory and then might be trying to find a very faint object, so they need to preserve their night vision. What do the students actually observe? Well, to start with, we give them a few suggestions to point them at interesting objects. But during the week, the students gain enough confidence to decide what they want to do with the time they have on the telescope. So we tell them about how they're going to be calculating coordinates, how they're going to be moving the telescope, how they're going to be using setting circles, until they've spent a night or two getting used to, yeah, where necessary, I can point it in the right direction and I know I'm pointing at the right galaxy. And then they decide what they're going to do with the remaining nights of observations. The sort of things they might study during the week could be, for instance, they might do star clusters, they might measure open clusters or globular clusters, and they would use different filters in order to analyse their data and generate Hertzsprung-Russell diagrams. Remember, for a Hertzsprung-Russell diagram, the vertical axis of the diagram is luminosity and the horizontal scale is colour. So if you take an image of a cluster in two filters, red and blue for instance, then by looking at the difference of red and blue you can get an indication of its colour. And you can plot on a colour magnitude diagram the magnitude of the star and its colour, and then you've got the makings of a Hertzsprung-Russell diagram. And you might be able to deduce from that Hertzsprung-Russell diagram how old the cluster is by looking at the particular pattern of stars spread over the HR diagram. Some will go for that, some will go for planetary nebula because they like the idea of looking at the stellar atmospheres that have been blown off some old stars, looking at the nebula in various filtered light, whether it be hydrogen alpha or oxygen 3 light. They'll be looking at the different structures of the planetary nebula, seeing what they can learn from looking at different planetary nebulae. Some will go for galaxies, and again they'll either take fully luminous images or they'll restrict themselves to H alpha, in which case they'll see the star forming regions of the galaxies, and combining the H alpha with the full luminosity they'll get an idea of where the star forming regions are relative to the spiral arms, for instance. They might also go for variable stars. It's a little more boring, simply measuring the magnitude of a star over the course of a few hours, but some will do that and collect their data and add it to data perhaps taken by other students to get the full light curve of stars that might vary over hours or perhaps over days. But essentially, once the students have got the idea of how to use the telescope and they've got an idea of the capability of the telescope, then we like to leave it to them to decide what their projects are going to be, and then they collect the data accordingly. If everything looks to be going well and the students are happily analysing their data in the warm room, then it's nice just to slip away from the supervision, as long as we've got plenty of staff to make sure the students are always safe. Then it's nice just to slip away to the back of the observatory where we've got that concrete standing, and then I can take my camera and stick it on a star tracker and take pictures of the beautiful Milky Way that you get out in these wonderful dark skies. It's also, of course, nice to take the students out and say, look, just for 15 minutes, just lie down there and stare at the sky. There aren't many opportunities you get to see a sky this dark. So just spend a few minutes and just look at the sky. Here's a pair of binoculars if you want to see more detail. And by the way, that's the galaxy, or that's the cluster, or that's the nebula that you've just been studying. But just drink it all in, because you've got to go with the experience of seeing the night sky like this. So this is a wide-angle shot taken with a wide-angle lens, taking a fair chunk of the Milky Way all the way down to Sagittarius and Scorpius there at the bottom of the image. So the centre of our galaxy is somewhere around here. Technically it's visible from the UK, but it's always very low down in the south and usually a little bit difficult to see. So it's nice to have it so clearly visible from the latitude of 28 north. The centre of the galaxy is nicely high in the sky. And I decided on this particular night to take wide-angle shots, and I thought I would switch to an 85mm lens and take just that area indicated in the red rectangle there, and if we blow that up you can see an enormous amount of detail with an 85mm lens. For those who know their way around the sky, especially this part in the richest part of the Milky Way, there's the Eagle Nebula up there. You can't quite see the Pillars of Creation. There's the Swan Nebula, or the Omega Nebula if you prefer, M17. There's the Trifid Nebula, M20. There's the Lagoon Nebula, M8. And I think there's probably another 20 Messier numbers in that particular area of sky. So with just a few minutes exposure and adding together a few images, you can get wonderful images simply because the sky is so dark you don't have to worry about any light pollution. This is a little montage, a little mosaic if you like. Although I usually take astrophotography images using raw images, I thought I would just see what it's like just to take some JPEG images. So this is the result of taking some JPEG images without any darks, without any flats, just 4 JPEG images and adding them together to make a mosaic of 4 JPEGs. Again, the Trifid and the Lagoon over on the left-hand side, spanning over to Scorpius. There's the red giant Antares and the globular cluster M4, and the Rho Ophiuchus, the multiple star with a little bit of nebulosity around it. Again, as well as the wide-angle stuff, I thought I would try concentrating on Antares. So there's Antares and 2 stars next to it in the constellation of Scorpius. There's M4, the globular cluster, and you get the beautiful contrast between the nebulosity around Antares and the blue nebulosity around the multiple star Rho Ophiuchus or Ophiuchus. And you get these dark lanes that are part of the extended Milky Way structure. These tendrils here go all the way towards the centre of the Milky Way. And that was taken with a 135mm lens. So I sometimes take a mixture of lenses because sometimes I like to capture the wide angle, sometimes I like to concentrate on some of these objects. But the beauty, of course, of sticking a camera on a star tracker is you can tell it to take a picture every minute or whatever it is you want, put it on the star tracker, and then go back indoors to check how the students are getting on. So the astrophotography can go on at the same time as the supervision of the students. I said that we might have a year in which we have 30-some students, and so we might have to have 3 field trips back to back. A batch of students, and then we swap another batch of students, swap another batch of students. Sometimes the staff stay at site, sometimes the staff come on and off with the students. So in other words, it might be a different 2 or 3 staff in the first week, and then perhaps a different 2 or 3 staff in the second week, etc. But if we do have to go over 3 consecutive weeks, it's not surprising that someone sooner or later is going to have a week in which the moon is going to be close to full, or possibly even through the transition of full moon. So that might affect the ability to take some of the fainter deep sky objects. It doesn't matter for the planetary nebula, it doesn't really matter for the Hertzsprung-Russell diagrams, it doesn't matter for the variable stars, but some of the fainter objects might not be possible during full moon. But this particular week, although I wasn't going to do some astrophotography of the Milky Way, I thought I would try some star trails. And you can see the full moon is illuminating the foreground there, the green grass and the white telescopes, solar telescopes on the right. These are 2 of the solars, the big one in the background there and the one in the foreground. This is just I think that one is an empty dome at the moment. But you can see that Polaris is relatively low in the sky because, of course, we're at 28 latitude, so Polaris is only 28 degrees off the horizon. But we are able to take star trails over 6 or more hours, and that's what I tried here, to try a 6-hour star trail. And it does look a bit odd to have the full moon illuminating the foreground and having a blue sky rather than a jet black sky. But it does mean that you can still do some photography, even if deep sky or Milky Way photography is a little bit compromised by the full moon. It's still possible to go out with a camera, and in this case, of course, without a star tracker, just a camera on a tripod, and in this case, exposed for as long as possible. I took a picture, I think it was every minute for 360 minutes over the 6 hours there to get the star trails approximately 1/4 of a revolution. You notice also Polaris is not a dot. Polaris is also a small arc, as it's of order 1 degree or so from the North Celestial Pole. Sunrise is at about 7:30 or so. So as the sky starts to lighten, we might take some sky flats in order to correct for the images taken on the CCD camera during the night. But generally speaking, soon after sunrise, we tend to go to bed and then get up sometime in the afternoon. For the staff, that means a quick cup of coffee, staring out Mount Tidy out in the distance there. For the students, they might get up early, they might sleep in all afternoon. Sometimes the students get up relatively early and start thinking about the analysis of the data they took the previous night, or some of them will start planning what they intend to use the following night for. They also have access to the Liverpool telescope. The Liverpool telescope is not on Tenerife, it's on the neighbouring island of La Palma. And the Liverpool telescope is the world's largest robotic telescope. It's a robotic telescope with a 2-metre mirror, research class, but students have access to approximately 20% of that time. Students at university and students at school. So 80% of the time it's used for research projects by Liverpool John Moores staff and other astronomers around the world, but students have access as well. So as well as teaching the students how to use a real telescope hands-on, we also say that if you ever intend to be an astronomer, you will probably be operating all of your telescopes remotely and robotically, so why not get used to that now? We are giving you a few hours of observing time on the Liverpool telescope. What would you like to observe with a few hours of telescope time, bearing in mind that you only need a minute or so to get some very nice images of objects? In some cases they indulge themselves and take pictures of pretty objects. In some cases they take data that complements the data they're building up using the MONS telescope, which they are obtaining manually. So again, it's nice that they can think about analysing the data from the Liverpool telescope as well as their own data on the MONS telescope when they get back to Liverpool to write up their projects. Best laid plans don't always work out. Occasionally there is cloud above 2,500 meters, although most of the time, because of an inversion layer, most of the cloud is down there below 1,000 meters and sitting on top of the resorts on the coast. Occasionally there is higher cloud. That usually disappears. Clouds during the day tend to disappear once the night comes and the temperature starts to drop. Occasionally it can get a little bit windy, and there are times when we've had to close the dome because the dome cannot stay open beyond a particular wind speed, which we are told by the authorities of the Tidy Observatory. But most of the time, in any given week, we can expect to have at least 6 uninterrupted nights of clear observing. I also mentioned that the best laid plans sometimes don't work to plan, and I mentioned the fact that the undergrowth is a little bit scratchy, which I found once when I accidentally put my arm into some undergrowth, which I won't give you the details about, but it gave me a little bit of a scratch. And I think 5 years later there was still signs of a little bit of a scratch on the forearm there. But I think the worst case was, okay, that was painful, but it wasn't actually that serious. What was a little bit of a problem was the fact that we always reckon on EasyJet or Ryanair flights to get us out to Tenerife and to get us back again, and when one group is coming back to England, the next group is flying out, and it's often the same plane. The plane that brings the next batch of students out is also the plane that takes the first batch back again. But you can see perhaps you can see from the top of this departure board, a flight that was supposed to go back to Manchester at 8 o'clock in the evening didn't actually fly back till 4 o'clock in the morning. So there was a horrible 8-hour delay at the airport where you can't do anything else and everything is closed down in the airport. So all you can do is sit there in the airport and buy bottled water, and that's about it. And it also means that for any staff getting back to the university the next day, it makes for a very tiring day if you've had an 8-hour delay, and instead of getting back soon after midnight, it's approximately a 4.5 hour flight. Instead of getting back to Manchester at 1 o'clock in the morning, you don't get back to Manchester till breakfast time, which means you don't get back to Liverpool until virtually the start of the teaching day. So it can be a little bit traumatic. But the experience of taking the students out on the field trip, there is nothing quite like it, because they go out there not knowing which end of a telescope to look down, and by the time they've had 8 nights on Tenerife, they have turned from students into astrophysicists, because now they know how to plan a night's observations, they know how to take the data, they know how to analyse their data, and they're all fired up for their next year's project and analysis and write-up of everything they did during that week. So I hope that gives you a good idea of what happens when we take our students to Tenerife for a week above the clouds. Thank you all for listening.
Wonderful. Thank you.